On the morning of April 13th, 2026, in a conference room in Hangzhou, China, a number appeared on a screen that made automotive engineers around the world go very quiet. 48.41%. That is not a software update. That is not a marketing claim. That is a Guinness World Record, independently certified, officially documented, and it represents something the global automotive industry spent over a century insisting could not be done at scale. If you are new here and you love stories about technology that genuinely changes the world, hit that subscribe button and the notification bell right now, because this is exactly the kind of engineering story we live for, and you do not want to miss what comes next. Now let us get into why that number should have been impossible. To understand why 48% matters, you need to understand something first. Every time you fill up a tank of petrol, most of what you are paying for never moves your car. It goes out the exhaust as heat, it soaks into the engine block, it bleeds off through 1,000 tiny mechanical compromises. A typical engine on a regular car uses roughly 30% of the fuel energy you pump in. The other 70% just vanishes. And for over a century, the entire engineering establishment has been locked in a slow, brutally expensive war to shrink that number. Nissan's own senior vice president of powertrain engineering, Toshihiro Hirai, put it bluntly in a public statement a few years ago. It took 50 years, he said, to increase thermal efficiency of conventional engines from 30% to 40%. 50 years of the entire global automotive industry pushing as hard as it could. Toyota's Dynamic Force hybrid engine, which debuted in the 2018 Camry, eventually reached 41% and was considered the peak of what mass production could achieve. Engineers published papers, executives gave speeches. 41% was declared essentially the finish line, the ceiling. The point where physics and practicality drew a hard line and said, "This is as far as you go." GEELY walked past that ceiling without blinking, and the way they did it changes everything. But first, you need to go back a little further, because this story did not start with GEELY. It started with a quieter warning shot that most of the world's automakers chose not to hear. BYD looked at how a traditional hybrid car worked and concluded the entire design philosophy was wrong. In a conventional hybrid, the engine and electric motor both fight to drive the wheels at the same time. The engine constantly revs up and down, chasing the road, drifting in and out of the narrow band where it runs efficiently. BYD's answer was radical in its simplicity. What if the engine never drove the wheels at all? What if it just ran at one single perfect speed, permanently, acting purely as a generator? The wheels would be fully electric. The engine would have exactly one job: sit at its most efficient operating point and make electricity. Nothing else. Ever. That single philosophical shift allowed BYD to tune their engine without compromise. The result, announced with their 5th-generation DM technology in 2024, was 46.06% thermal efficiency. The global press called it extraordinary. Legacy automakers called it a regional phenomenon. They said Western consumers would not accept it. Engineers quietly reminded each other that people said the same thing about Japanese cars in the 1980s. And while the industry was still debating how to respond to 46%, GEELY had already been working on something that would make that number look like a warm-up. For context on just how fast this has moved, GEELY themselves hit 43.32% back in 2021. They pushed that to 46.5% on the BHE15 platform. Then 47.26% with the addition of full domain AI integration less than a year before this announcement. Each time, the industry noted it and moved on. Each time, GEELY went back to the drawing board and kept going. The first thing they rebuilt was the combustion itself. And to understand what they changed, you need to picture what actually happens inside a cylinder every time a spark plug fires. When air and fuel get pulled into the chamber, they do not mix evenly. Think about pouring cream into coffee without stirring it. You get uneven patches. Some areas too rich with fuel, others too thin. When the spark fires into that uneven mixture, the flame does not explode all at once. It starts at the plug and slowly creeps outward, like a ripple on water. And while that ripple is crawling across the chamber, the heat from the first burst of fire is already bleeding into the surrounding metal walls. By the time the full charge is burned, a significant chunk of energy has simply left the building. GEELY's engineers designed a solution they call the wind ride tornado combustion system. They completely redesigned the shape and angle of the air intake channels, including what they describe as a duckbill intake geometry, so that when the valve opens, the incoming air is not pulled in passively. It is forced into a high-speed spinning vortex, a controlled tornado inside the cylinder. When the spark fires into that spinning mass, the flame does not creep. It erupts outward in every direction simultaneously because the fuel and air are already blended perfectly from the turbulent rotation. The combustion is sharp, synchronized, and almost entirely directed downward onto the piston. Less heat escapes into the walls. More force goes exactly where you need it. The engine runs at a 15.5 compression ratio with a 500 bar peak injection pressure numbers that would have destroyed a conventional engine design within hours. Which brings us to the second problem they had to solve. Cranking up compression and combustion intensity like this creates a serious risk of engine knock, where fuel ignites before the spark plug even fires, sending an uncontrolled shockwave through the engine that can crack pistons and destroy the whole thing within minutes. This is the exact wall that kept engineers stuck below 41% for decades. More compression means more efficiency, but it also means more knock. Nobody had found a clean way through that trade-off. But if you think that was a difficult problem, what GEELY did next made it look simple. They made the engine run hot and cold at the same time, in different zones, deliberately. In a normal engine, the cooling system sends water through the entire block at roughly the same temperature. A single compromise that treats the top and the bottom of the engine as if they need the same thing. They do not. GEELY split the cooling system into two completely independent circuits. The very top of the engine, where the explosions happen, is kept aggressively cold. Coolant moves fast and pulls heat away the instant it appears, keeping the incoming air charge dense and cool right up to the moment of ignition. That prevents premature detonation and allows the engine to run at compression ratios that would be catastrophic in a conventional design. Meanwhile, the lower block, where the pistons slide up and down thousands of times per minute, is kept deliberately warm, because warmth thins the engine oil. Thinner oil means the pistons slide with dramatically less friction. According to GEELY's own technical documentation, the system achieves a 16.3% reduction in total friction losses through precision ground components, diamond-like carbon coatings, and ultra-low viscosity oil. Two goals that have always been enemies in traditional engineering: extreme compression at the top, minimal friction at the bottom, both achieved simultaneously in the same engine, because GEELY built two thermal environments inside one block. The third piece of the puzzle was the drivetrain. Because even the most efficient engine ever built is worthless if you bleed that efficiency away fighting through a heavy, complicated gearbox to reach the wheels. Traditional automatic transmissions are mechanical achievements, but they are also full of friction. Hundreds of moving parts, clutch packs, torque converters, shift forks. Every single component absorbs a little bit of the energy you just worked so hard to generate. GEELY threw the gearbox out entirely. What they built instead is called the 11-in-1 Integrated Electric Drive System. It packages the engine, the generator, two electric motors, the high-voltage inverters, and the thermal management hardware into a single compact housing. There are no shift forks, no hydraulic fluid channels, no torque converters. Under standard driving conditions, certified testing shows the electric drive is active in more than 80% of scenarios, reducing the time the combustion engine even needs to run by over 27% compared to a conventional hybrid. The whole experience from inside feels like a fully electric vehicle. Silent, smooth, instant torque from a standstill. The only moment the system physically locks the engine to the axle is at steady, high-speed highway cruising, where routing power through the electric motors would actually waste more energy than a direct mechanical connection. The system detects that condition automatically and switches modes without any input from the driver. Sitting above all of this is an AI energy management platform called AI Cloud Power. It reads real-time data on temperature, humidity, altitude, and your navigation route. It spots the hill coming ahead, calculates whether to charge the battery now and coast on the descent, or use the battery now and let the engine recover on the way down. It continuously finds the most efficient way to route power in a way no human driver ever could. The combined result of the tornado combustion, the split thermal zones, the frictionless drivetrain, and the AI management layer is a Guinness-certified fuel consumption of 2.22 liters per 100 kilometers achieved during a dedicated highway loop test on Hainan Island and verified as the world record for a mass-produced hybrid vehicle. To be clear, real-world WLTC figures for the Preface and Manjaro are closer to 4 liters per 100 kilometers, still exceptional for vehicles of their size, but the record number reflects optimal highway conditions, not average daily driving. Here's where the story stops being just about engineering and starts being about something larger. For well over a century, the combustion engine was a European and Japanese domain. Germany invented it. Japan spent 50 years refining it to what everyone assumed was near perfection. The argument inside boardrooms across Stuttgart, Munich, Tokyo, and Nagoya has been that the future is fully electric, and therefore investing further in combustion was throwing good money after bad. While those conversations were happening, engineers in China were asking a different kind of question. Not how do we replace the combustion engine, but what if we actually finished building it? The result is a technology gap that cannot be closed with a press release or a firmware patch. Geely's founder Li Shufu personally holds close to 10% of Mercedes-Benz Group, making him one of its largest individual shareholders. Geely Holding has owned Volvo cars outright since 2010. Its Horse Powertrain joint venture already licenses engine technology to Western manufacturers. The efficiency advantage Geely has built is not sitting behind a wall in China. It is already moving into the global supply chain, with the iHEV rolling out across the Preface, Manjaro, M Grand, and Boyu throughout 2026.